Bismillahirrahmanirrahim. Assalamu alaikum dear students. This is your instructor Anisa Nawaz from Department of Physics. This is our lecture number 21 from chapter number 2, Vectors and Equilibrium. In the previous lecture we have discussed about torque and the factors affecting torque. We have discussed in detail that what is the equation of torque and what are the factors upon which the torque is dependent. After listening to today's lecture, you would be able to understand that what are concurrent forces, what are equilibrant forces, and what is moment of a couple. So first let's discuss about concurrent forces. If we are going to define concurrent forces, when two or more forces are acting on a body and the line of action of these forces pass through a common point, the forces are said to be concurrent forces. Okay, we have already discussed in previous lecture that what is line of action of forces. Okay, so line of action of force is an imaginary line. Basically when we are extending the force, then we are drawing that line, that imaginary line, that will be known as a line of action of the force. So if we are having more than one forces, okay, if you are having two or more than two forces, they are acting on a single body and the line of action of these forces pass through a common point, then these forces are known as concurrent forces. Okay, so condition is that they should act on a single body. Okay, for example, if we are having a piece of meat, let's say that this is a piece of meat, okay, and we are having three dogs which are pulling this piece of meat, then how we are going to explain the forces applied on this piece? Let's say we are drawing this coordinate axis, we are having x and y axis, and we are having force F1 which is being applied by the first dog, we are having force F2 which is being applied by second dog, and force F3 which is being applied by third dog. All these dogs are pulling this single piece of meat towards themselves. Okay, now what we will do, we will draw the line of action of all these forces. You can see line of action of F1 is this, line of action of F2 is this, and line of action of F3 is this one. Okay, and now you can see that if we are removing this piece of meat, you can see this thing that all these forces are passing through a single point. Okay, so it means that these forces are concurrent forces because their line of action is passing through a common point. Okay, secondly, we are going to define equilibrant forces. What are equilibrant forces? Let's define that. Equilibrant force, two or more concurrent forces can be balanced by a single force called equilibrant force. Okay, if two or more than two forces are acting on a single body such that their line of action are passing through a single point, those forces can be balanced by a single force which is known as equilibrant force. Okay, equilibrant force is equal in magnitude to that of resultant force, but it acts in opposite direction. If you remember that we have discussed similar problem in assignment 2.3 in which we have to find a single pole that has to replace the given forces and balance the given forces system. Okay, so part B which we have done, balance the given forces system, was similar to that of equilibrant force. Okay, so what is there? We are having a resultant force of the whole system, and we are drawing a force which is equal and opposite to that resultant force which is balancing the resultant force. It will be known as equilibrant force. For example, you can see that if we are having two forces, let's say F1 and F2, okay, we are drawing these two forces and these are concurrent. These are, their line of action is passing through a common point, so these two forces are concurrent in nature, and we have to draw the resultant first. Okay, let's say F1 is 763 Newton, we have to draw the resultant, so we have to draw this second force over here. For head to tail rule, you can see this, let's say the second force is having magnitude of 525 Newton. Okay, and we are drawing their resultant Fr, which is 926 Newton, okay, and it is at an angle of 34.5 degrees. This Fr is resultant force. If we are going to find out equilibrant force, then what we have to do? We have to draw a force which is equal in magnitude to Fr but opposite in direction. Okay, such a force will be known as equilibrant force, a force which is equal in magnitude to that of resultant force but it is opposite in direction. You can see their magnitude is same but their direction is opposite. So this type of force is given a name, equilibrant force. Okay, next we have discussed in detail about torque. That what is torque? Torque is moment of a force. Okay, torque is moment of a force. Now we are going to discuss moment of a couple. Okay, for that first discuss what is a couple. Couple is defined as two parallel forces that have the same magnitude but opposite directions and are separated by perpendicular distance d. Keep this in mind that their line of action must not pass through a single point. If their line of action is passing through a single point, then they will not be couple. Condition is that they must be separated by a perpendicular distance d. Okay, two parallel forces, they must be parallel. They have same magnitude but their direction must be opposite. You can see over here we are having two forces F1 and F2 which are equal and opposite to each other. One is in this direction, other in this direction. Okay, they are parallel to each other and they are separated by a distance d. Okay, if we are extending their line of actions, you can see that they will never ever pass through a single point. So such type of pair of forces is known as a couple. Two parallel forces that have same magnitude but opposite direction and are separated by a perpendicular distance d. This is known as a couple. Okay, so what is happening in the couple? Resultant force is 0. Okay, you can see that they are equal in magnitude but opposite in direction. The only effect of a couple is to produce rotation. Okay, what they have to do, they can produce rotation because their resultant is 0. If they are having some resultant, then they can displace the body, but as their magnitude is equal to each other, just their direction is opposite. So what they can do, couple can only produce rotation. And if no movement is possible, there is a tendency of rotation in specified direction. Okay, there is tendency means it will tend to rotate the body. Okay, but there is no linear motion because the magnitude of two forces are equal and opposite. For example, while making a turn during car drive, if both hands are on steering wheel, one hand will push up on the wheel while the other hand pulls down. You can imagine that if we are driving a car and we are turning the steering wheel while making a turn, our one hand is you can say it is pushing up on the wheel and the other hand is pulling down. Two equal and opposite forces acting on a single body. Two equal and opposite forces will act which cause steering wheel to rotate. Okay, so these forces form a couple. These two forces which are being applied by our hands, they form a couple. Okay, you can see this type of figure is there. If we are having a steering wheel, one force is applied in upward direction and other in the downward direction. You can see that, let's say this is point O, central point. Okay, the distance from point O to A is given by the position vector RA. Distance from point O to point B is given by the position vector RB. Okay, RA and RB, this is point of application of force point A and point B. We are having FA, first force which is being applied on A. Okay, and this is FB, which is F. You can take any of these two forces as positive and other as negative because they are having equal magnitude and opposite direction. So we are taking over here FA is equal to minus F and FB is equal to F. Okay, so we are applying two equal and opposite forces on the steering wheel which will produce rotation. So these two equal and opposite forces are known as couple. Okay, so what is moment of a couple? The the moment produced by couple is called a couple moment. I have already explained this thing, that whenever there is the word of moment, there is some turning effect, so rotation, some turning effect. So the moment produced by couple, the rotation, tendency of rotation, it is called a couple moment. Okay, or we can find out moment of a couple by finding moment of both forces which form couple about any arbitrary point. Means we can separately find out the torque produced by the forces and then add that, and then what we will do, we will find out the moment produced by that couple, by those two forces. We will separately find out moment produced by the individual forces. Let's say we are having FA, force FA is equal to minus F, and force FB is equal to F. Okay, as RA, position vector RA is directed from O towards A, lying on the line of action of force FA is equal to minus F. You can see point A is on the line of action of, you can see over here, A is on the line of action of FA, and RA is directed from O towards A. Where is A? Lying on the line of action of force FA. Okay, and RB is directed from O towards B, directed from O towards B, and where is B? Lying on the line of action of force FB. Okay, so we are having factors FA, FB, RA and RB. Now what we will do, we will calculate the moment produced by these forces. The couple moment determined about O is, first, if we say that net torque, net moment which is produced over here, that is equal to the sum of individual moments, or we can say that tau is equal to tau A plus tau B, or we are adding the moment produced by the individual forces. Or we can say we are putting the values, tau is equal to R cross F, we know that, so tau A will be RA cross FA. Tau is equal to, we are putting the value of tau A over here and we are putting the value of tau B over here, RA cross FA plus RB cross FB. Okay, we know the values of FA and FB, so we are going to put those values over here. Tau is equal to RA cross minus F plus RB cross F. We are putting value of FA and FB in this equation. We know that we can take F as common. We are going to take F as common factor. Negative sign is with RA, then what we can write, we can write it as RB minus RA cross F. We are taking force F as common and rest of the terms are RB minus RA. So we are writing it as RB minus RA cross F, and this RB minus RA is giving us the position vector R. Okay, this negative sign is just due to the direction. So this RB minus RA, just like we have discussed in the case of position vectors, that RB minus RA will give us position vector R. So tau is equal to R cross F. Okay, so we can write it as tau is equal to R cross F. So we can say that if we are applying these two forces on anywhere on the line of action over here, if you are applying FA and FB anywhere on the line of action of these two forces, then they will produce same effect. Okay, they will produce same effect. Their perpendicular distance should be the same, so they will produce the same effect. So we can say that the couple is basically forming a free vector. Okay, we can apply those forces anywhere on the line of action of these forces. Okay, so this is forming a free vector. So direction of couple moment, if we are going to find out the direction of moment of couple, you have already seen that moment of a couple is having same formula as that of torque. Tau is equal to R cross F. So its direction of couple moment can be determined by right hand rule. We can calculate its direction by right hand rule. Okay, and its direction is always perpendicular to the plane containing these forces. Okay, if we are having the direction, it is always perpendicular to the plane containing these forces. You can see over here two forces are applied on the steering wheel. Okay, one in this direction and the other in this direction. These two forces are parallel to each other and they are separated by a perpendicular distance d. We are going to find out their direction of the moment of the couple, so we will use right hand rule over here. We will curl the fingers of our right hand from the direction of one force towards the other. Then we will find out that this thumb is giving us the direction of moment of couple. Okay, this thumb is giving us the direction of couple moment. Okay, so same is the case with if we are applying torque, that is simply the summation of the torque. We are having two forces which are producing torque and we are adding those two torques. Okay, but the specified condition is that these two forces must be parallel to each other, they should be equal in magnitude and their direction should be opposite to each other. Okay, so this type of forces, these type of forces are forming a couple, and moment of the couple is basically the turning effect produced by the couple. Okay, its direction is given by the right hand rule. Okay, now if we consider the example of a crane, torque applied on the example of a crane, how it is done. We know that if you are having a crane is used to lift heavy loads. It is in your book, a crane is given, this crane is having this longer part, this one is known as boom, and it is lifting this heavy load, and we are having a weight, a heavy load which is present on the crane, which is known as counterweight. Okay, this heavy load which is present on the crane, it is known as counterweight. So why this counterweight is important, what is the function of this counterweight, we will see this thing, but this longer part is boom. Okay, so what is happening over here, mobile crane, counterweights. Mobile crane means its boom can be moved here and there, and it can you can say lift the weight from one place and leave it at some other place. So mobile cranes are vehicles designed to lift, lower and transport heavy loads. Okay, so this is the function of mobile cranes. A mobile crane moves the heavy loads. Okay, already discussed that. The shorter end of the beam is applied by a force. Okay, we are applying the force on the shorter end. The longer end, called boom, can rotate and move the load radially inward or outward to position the object at correct position. So with the help of boom we can move the load from one place to another place. Okay, since boom is having large length, even a small load lifted at its end will produce a large torque, and there is a danger for the crane to topple over. You can see over here, this is having a long length, this boom is having a long length. So if we are lifting this load over here, this load, this force is basically applied over here, we are applying a force over here, and this is acting as moment arm. So force and moment arm are there, they will produce a torque. Due to this torque, what is the danger? The danger of toppling over the crane. The crane will topple over. Okay, due to this heavy load, what can be done, what can happen over here, the crane can topple over. There is a danger of toppling over the crane. Okay, because according to the relation tau is equal to r cross f, if we are having a long moment arm, then even a small force can produce a larger torque. This is the case over here. So to prevent this thing, to prevent this torque produced due to this load and this long length of the boom, what should we do? We should apply counterweight. To overcome this situation of toppling over, cranes have a counterweight at the other side that moves in an opposite direction from the object that is lifted. Okay, so you can see over here, these types of you can say heavy loads are present on the cranes. Okay, these heavy loads are present on the cranes which are moving in the opposite direction to that of the heavy load. For example, on the other end of this crane, we are lifting a heavy load, and this counterweight will move in the opposite direction. So what will happen? It will produce a counter torque, a torque which will balance the effect of that torque which is produced by the load. Okay, so this counter torque, counterweight, what is doing it? By it, the counterweight exerts a torque on the crane in equal and opposite direction to the torque from the load. So it is applying a torque which is equal and opposite to that of the torque which is applied from the load. Mathematically, we can say that torque applied by the boom is equal to torque applied by the counterweight. So these two torques are equal to each other, their direction is opposite, so they will cancel the effect of each other, due to which the danger of toppling over of the crane is reduced. Okay, so that's why counterweight is an important safety measure, because without counterweight the crane can topple over. The torque of the boom is equal to torque due to the counterweight. So that was all for today's lecture. I would like to end my lecture with this quote of again Quaid-e-Azam Muhammad Ali Jinnah. He said that develop a sound sense of discipline, character, initiative and a solid academic background. You must devote yourself wholeheartedly to your studies, for that is your first obligation to yourselves, your parents and to the state. You must learn to obey, for only then you can learn to command. Okay, so think on these words. These are very deep words. What you have to do, your first obligation is your studies, to yourselves, your parents and to the state. And another thing, you must learn to obey. If you don't learn to obey, then you can't be able to command. Okay, so thank you so much. That was all for today's lecture.